Good morning, students. Our today's topic in the topic of periodic table is Group 7, the halogens. So concentrate yourself. Here are halogens: fluorine, chlorine, bromine, iodine, astatine. Halogen molecules F2, color pale yellow and state at the room temperature is gas. Chlorine, its color is yellow green and its state at the room temperature is gas. Bromine and iodine, they are at the room temperature are liquid and solid respectively. The bromine is having color orange, brown, and iodine is having color gray, black, violet vapor. Okay, all elements in this group have 7 electrons in their outermost shell because they are actually group 7. So all the elements which are in group 7 having 7 valence electrons. And here are the electronic configurations. You can see in every element there are 7 valence electron in the outermost shell. Halogen exist as diatomic molecules and are all colored. So you have learned from the table they are all colored and diatomic molecules. Their atomic number is 1 less than the noble gases accordingly. Now we are going to read their general physical properties. They are non-metals. They are having low melting and boiling points, so their liquids exist only over a very narrow temperature range, and after that they are converted into vapors. They are non-conductors of the electricity because they do not pass electricity from them. Their ionization energies are high, in fact second only to those of the noble gases, hence they are strongly electronegative. They dissolve readily in organic solvents such as tetrachloromethane. They exist as simple diatomic molecules as they can readily combine with another atom of its kind to attain stability because they make covalent bonds of with the same kind of the atoms. So they exist as diatomic molecules. All elements in this group have 7 outermost electrons. The group 7 elements are not found free in the nature as they are reactive. Fluorine is the most reactive. Okay, variation in physical properties as you go down the group. Atomic radii increases as you go down the group. Densities increases. Melting and boiling point increase due to increasing strength of the intermolecular attraction. Color intensities of the halogen increases. So as you go down the group, the color intensities of the elements becomes more strong. Chlorine gas greenish yellow, bromine liquid and reddish brown. Iodine is solid and having black color. General chemical properties are they are oxidizing agents. They gain 1 electron each to form negative ions. Variation in chemical properties down the group. As you go down the group, their reactivities decreases. There is ease of gaining 1 electron decreases with increasing atomic radius and decreasing nuclear attraction. So the reason is ease of gaining 1 electron is decreases with increasing atomic radius. So as you go down the group, the attraction between the protons of the nucleus and the outermost shells becomes weaker. So they feel very easy in gaining the electron. And as you go up the group of 7, so atomic radius reduces. There is more attraction between the outermost electrons and the protons of the nucleus. So they feel difficult to gain 1 electron. So this is the reason which you are reading again and again in different groups. Reaction with water. Halogens react with water to form acidic solution. That is general equation is here. X2 plus H2O forms HX plus HOX. Solutions have oxidizing properties. Reaction with alkalis. Halogens react with alkalis to form salts and water. General equation is X2 plus 2NaOH forms NaX plus NaOX plus H2O. Reaction with alkali metals. They react violently with alkali metals. Here is the general equation: 2Na plus X2 forms 2NaX. Reaction with non-metals. They react with most non-metals to form halides in which the bonding is covalent. For example, reaction with phosphors. Here is the reaction: 2P plus 3Cl2 forms 2PCl3. So they normally form non-metal halides. Next is reaction with hydrogen. They combine with hydrogen to form gaseous covalent hydrides, which dissolves in water to form halogen acid. So H2 plus Cl2 forms ACl. Chlorine is used as bleach. It reacts with water. Cl2 plus H2O forms ACl plus HOCl. Bromine is less reactive than chlorine. It is also a weaker bleach. So chlorine is reactive with water, so it acts as a bleach. Bromine less reactive than chlorine, but it is also a bleach but weaker. Iodine is even weaker. The iron and the chlorine react fiercely. Red-brown iron chloride is made in the reaction. So 2Fe plus 3Cl2 forms 2FeCl3. In general, we say that the halogens form halides. Halogen halides are gaseous compounds that are very soluble in water, forming strongly acid solutions. So they are soluble in water and forms acidic solutions, and the compounds of the halogens are called halides. These are the points to remember. Bromine forms bromide. So look now, halogen forms halide, bromine forms bromide, iodine forms iodide. Bromine does not react with iron as quickly as chlorine. Iodine is even slower. Remember that the properties of the elements are completely different from those of the compounds they form. So this is another very important point to remember. The elements are having different properties and their compounds are having entirely different properties. We find that the halogen get less reactive as you go down the group and gets more reactive as you go up the group. An atom of halogen has 7 electrons in its outermost shell. It needs to gain 1 electron to fill up its outer shell. A fluorine atom is a lot smaller than the iodine atom. Therefore, an electron entering the outer shell of the fluorine is nearer to the attractive forces of the nucleus. The electron is attracted more strongly. So this is the reason. Halogen in competition. So look now, as you go up this series, they are more reactive. So if they are more reactive, they will displace the less reactive. So here is the explanation. Chlorine is more reactive than iodine or bromine. It can displace bromine and iodine out of the solution. So if in a reaction at the same time chlorine and bromine comes, because chlorine is more reactive, so it will displace bromine from the reaction. So it will take the place of bromine. So products will become 2KCl plus Br2. Br2 is expelled. Bromine is more reactive than iodine. So if bromine and iodine comes in the reaction, so bromine will push the iodine out of the reaction. So can it displace iodine? The answer is yes. The next thing that we are going to read is the halogens and their compounds and their uses in daily life. So first we are going to read fluorine. Fluorine is the most reactive of all the non-metal elements because it is at the top of the group. So as you go up the group, the element becomes more reactive in the group 7, and as you go down the group, the elements becomes less reactive. So because fluorine is at the top, so it is most reactive. It even attacks glass. However, some of its compounds are useful. Teflon is a fluorine compound. It is non-stick lining on the pans. So this is the first common use in daily life. In lining the cooking pans, fluorine is used. Next is most toothpaste contain fluoride to prevent tooth decay. So this is an other use of the fluorine. Next thing which we are going to read is the uses of the chlorine. So here are some uses of the chlorine. So chlorine is used for killing bacteria in drinking water. It is used as pesticides and weed killers in farming. It is used as hydrochloric acid. It is used as bleach to kill bacteria and to whiten paper. It is used for killing germs in your sewage. It is used in dry clean. It is used to killing bacteria in swimming pools, and it is used to as a antiseptic and disinfectants. So these are some of the uses of the chlorine, which normally comes in the paper. You have to remember at least 4 or 5 uses out of them. Next thing that we are going to read is bromine. Bromine is used in pesticides. It is also used to make medicines. Silver bromide is used in photographic films. Next thing that we are going to read is iodine. Iodine is an antiseptic. It is dissolved in alcohol and put on to cuts. Can be used before operations. And here is a picture. So that is used as an antiseptic. Okay, halogens working for or against us. So this is a debate which is going on. The halogens and their compounds have had both good and bad effects on the world. Chlorine has had a bad reputation since it was used the first chemical weapon in the First World War. So chlorine has a very bad impression. Its compounds are also used in biological nerve gases. So that are the bad uses of the chlorine. However, chlorine used in killing bacteria in drinking water has saved millions of the lives around the world. It has greatly reduced the number of the cases of the cholera. Yet even this use is now being questioned. Scientists are carefully measuring the poisonous compounds that the chlorine makes after it is added to our water supply. These poisons were first noticed in discharges from paper mills. Chlorine is used to make paper white. Paper manufacturers now use less chlorine gas and are looking for new ways to bleach paper. So these are the bad and good effects of the chlorine. Halogen-based pesticides have reduced deaths caused by the disease carried by insects such as malaria. They also reduces the loss of the crops in storage by killing the bacteria, so food can be preserved for a long time. On the other hand, these compounds can affect other wildlife in the food chain. So other animals in the food chain becomes dead. That's why food chain is disturbed, which can, in the long run, which can affect the production of the crops as well. Halogen compounds are also damaging the ozone layer. Scientists predicted that more cases of the skin cancer and eye contact. So these are the bad effects of the halogens. CFCs are now being phased out, as are other halogen compounds used in fire extinguishers, flame proofing, and solvents. However, because they are so long lasting, CFCs will remain in the atmosphere for many years to come. So this is this debate which is going on. Either halogens are good or bad. So they have good effects as well as they have bad effects. This is very important question which normally comes in the paper, carrying 2 to 3 marks or 3 to 4 marks. So you have to remember, you have to learn the good and bad effects of the halogen. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.